When dealing with alternating series, there are actually two types of convergence. So if we have a series that converges, we say it converges absolutely if the absolute value of a sub k converges. Otherwise, it converges conditionally. So if it's an alternating series that converges and the absolute value does not converge, we'll say it converges conditionally. However, if they both converge, it'll converge absolutely. And in general, if the absolute value of a sub k series converges, then a sub k converges. So basically, if it converges absolutely, then it converges conditionally. In addition, if it diverges conditionally, then it will diverge absolutely. So if the series a sub k diverges, then the series of the absolute value of a sub k will also diverge. So for instance, let's look at this one. We know that the square root of k plus 1 is greater than the square root of k, which means 1 over the square root of k plus 1 is less than 1 over the square root of k. So we've satisfied our first condition for an alternating series converging. In addition, the limit as k goes to infinity of 1 over the square root of k is 0. So this thing definitely converges conditionally. What about converging absolutely? Now I'm looking at the series of 1 over k to the 1/2, so we're going to rewrite this. And this is a p-series. Since 1/2 is less than 1, it diverges. So this particular series will converge conditionally, since the alternating series converged. However, the absolute value series did not converge. Next, let's look at this one. So I see that if I look at the positive, the absolute value, and I rewrite the denominator, I get 1 over k to the 3 over 2. So this is also a p-series. And in this case, 3 over 2 is bigger than 1, which means it converges. So the absolute value here does converge. And my theorem says if it converges absolutely, then it converges conditionally. So I don't need to check the alternating series. Since this series converged, the alternating series will also converge. So this one doesn't quite look like an alternating series. However, it is because of this sine k. Looking at whole numbers, it will slowly move between positive and negative. It may not be every single term that switches, but in general it will switch. And we can see that sine of k over k squared is less than 1 over k squared. And since this series right here will converge, so will this one by our limit comparison. Or not by the limit, just by the comparison test. And we can also see that not only does this converge, but if I move the absolute values, the absolute value of sine of k is still going to be less than or equal to 1, which means this still converges by the comparison test. So this one absolutely converges, since the absolute value here did converge. One last one. Here, you'll notice that if I take the limit as k goes to infinity of k over k plus 1, I get 1, which means this diverges no matter what. My alternating series test said that this limit had to be 0. It's not. So this series will diverge.